Hello guys, welcome back. And today I'd like to talk about the chapter 13, discrete random variable. I know from this year to 2020, we are not really need to know what do we mean by discrete random variable, but it is essential for us to understand or have the fundamental understanding of probabilities, and sometimes we still need to use it in binomial distribution. So personally, I think still is worth to share with you guys and pick up the really important thing for you guys to be, familiar with and should understand. The first one is random experiment and simple space. Of course, random experiment is pretty straightforward. We just expected our experiment to do randomly and without like the script or without like plan, you know, to manipulate the data and discharge the data we do want. And the simple space essentially just means all the possible outcomes you have to include in one set. So if you play a dice, so the simple space for that will be 1, 2, 3, 4, 5, 6. You have to count for every outcome. Okay. If you're doing the flip or toss a coin, it's gonna be head and tail for both. So for next essential part is union and intersection. Okay. This one we covered long time ago and same as well as the Venn diagram, okay, to illustrate what do we mean by intersection, what do we mean by union, okay. Another important thing is tree diagram. So sometimes we can easily change the word problem, convert it to tree diagram, and keep all the information, and we can understand the relation or the link between the conditions given. Okay, so tree diagram is important. Just make sure each branch you adding them together, the probability will be 1. Okay, and the next one should be emphasized here is a dash in here. A dash essentially means the complement of A. So if A is an event like, okay, you are watching my videos, so my A dash will be you did not or you do not watch my videos, so it will be the opposite. Okay, and another thing is if we consider two events, they have no outcomes in common, we call them mutually exclusive. Okay, or we call them disjoint. So essentially this is can never happen at the same time. For example, if you're taking the SAC, 50% of the chance you get A plus, and 30% of the chance you got A, and 20% of the chance you got B. So each of them are mutually exclusive with each other because inside the one SAC, you cannot get A plus and A at the same time. You only can get one of them. Okay, this is called mutually exclusive. And of course, intersection with these two things will be 0 because they never ever gonna be happen together. And another thing I'd like to emphasize here is probability table or probability from area. Of course, the area thing is my 1 will be my total area, and my uh, numerator or my things I want is a smaller area. So I just use a smaller area divided by total area to give me the probabilities. And the next one, pretty important, is probability tables. And for this one, I personally suggest you do know how to fill the table is, and it's pretty straightforward, but it's quite useful because sometimes your final year exam just gonna ask you this one, and this one will not be provided for you. Okay, if I remember correctly, 2017 exam 1 they gave 4 marks about this probability table, but I'm assuming this year they're not going to test you this because they, you know, because of the coronavirus, and this chapter is really not testing. But again, just follow up your teacher's lead and to know what exactly get rid of and what other things they still gonna be tested. And next one is pretty important is conditional probability. So conditional probability is essentially just like they give you another extra information to help you to define or refine your probabilities. Okay. As for example, probability A, we can make, okay, after school study at home. So normally maybe this is 20%, hopefully, or even higher. And I give you another condition like B, like, okay, the teacher can tell you tomorrow we're gonna have the assessment, or tomorrow we're gonna have the progress quiz. So based on this information, given B and your study probability at home will maybe increase to 100% or like 80% or like 50%. So with extra information, your probability change up or down. Then we call it conditional probabilities. And the formula is given by this. But of course, we have some certain of things like you not really care. Even I'm telling you like B is happening or not, you probably never change. Then we call them independent. Okay? Make sure you can distinguish between independent event and mutually exclusive event. So for independent events, they can happen together, and it's based on the conditional probability. And if not, if they cannot happen together, it's called mutually exclusive. Okay, make sure you get this one. And for mutually exclusive, probability A intersection with B will be 0, but for independent event, it will equal to separate probability times each other together. Okay, this is conditional probability, and make sure you guys try this question. It's pretty interesting, and the hint I give you here is the tree diagram. Okay, so this will be on page 567, question 13. Okay, so the next one is give you guys what do we mean by discrete random variables. So discrete is essentially just means countable. You can count all the outcomes. And for this one be discrete random variable, two things you have to meet together. First one is for each of the probability must lies between 0 to 1, and for every for every probability you adding together will be 1 as well, because we like the 100%. Okay, and for this px we sometimes give the name called discrete probability function, or we call it probability math function. Okay, for this one, this is just like math terminology. Make sure you know it's essentially just like probabilities. So I give you some things to check. So for the first one, they ask you if this is a probability distribution. Of course, it's not, because we adding the probability is larger than 1. Okay, but for B, some people are a bit confusing. They're gonna say third x will be -1, so it won't be the probability distribution. But actually it is, because we only care about the probabilities, which in this case, they all 0.25. So for the x value, it's essentially the value you decide to take, or the question telling you to take. Okay, so -1 maybe just simply mean you lose 1 money, you lose $1. 0 just call it even. 1 maybe just like you earn 1 extra. 2 maybe just like you earn extra $2. So the x value is not going to affect our probabilities. So actually B is probability distribution. But for C, it's not, because it got negative. For D, again, it is, because each of them lies between 0 to 1, and add them all together, we got 1. Okay. So for 13D is another thing to know what to mean by expected value, variance, and standard deviation. So expected value is just like simply means mean. Okay, it's actually come from the gambling. So for expect value, it's basically tells us it's not amount we expect to profit for any one game. It is amount that we expect to win on average per game in long run. Okay, so which means if expect value is positive, it's a good thing. And if the expected value is negative, it's really bad thing. So once you look at example 15, you're gonna know what I'm talking about. And for this one, just to make sure you never go to Chrome, okay? If you want to make money or if you want to yourself be rich. If you want to just play, have fun, it's okay. But for each of the game in Chrome, the expect value for them will be negative. You can try and read the rule and do your own calculation, okay, to calculate the expect value by using this formula, okay. And same thing apply for the variability, which means the variance and standard deviation. So for high school, we just need to know if the variance or the standard deviation is larger, our data just spread far away from mean, which is if this one is your result, your variance is bigger, just simply means you are not stable, and maybe some good topic you can get really good marks, and some topics you don't care and you just lose interest, you just did really bad, okay. And this is a formula we will use to calculate variance: ex squared minus ex whole bracket square, okay. And this will be end of chapter 13. So takeaway message will be, what do we mean by mutually exclusive event? What do we mean by conditional probability? And what do we mean by independent event? And also, what's the mean and the variance standard deviation going to tell us? Okay, to make sure it is discrete random variable, we have to make sure that probability lies between 0 to 1, and adding all of them is 1. Okay, hopefully this video just quickly remind you, refresh your memory, and help you understand slightly more about probabilities. And for next one, we're going to move on to the binomial distribution. Okay, if you think my video is helpful, please subscribe and click the like button. And I see you guys for the next videos. Bye bye.